Hello, and welcome to Gain Enterprise Visibility with AWS Cloud Operation Dashboards. My name is Rich McDonough. I am a Specialist Solutions Architect with Amazon Web Services. I'm joined here by Amulya.
I'm Amulya Sharma, Principal Solution Architect, working with our strategic accounts at AWS, and I also focus on observability.
So this will be quite a packed agenda. We have a lot of material to cover, and we're confident that you're going to leave here today with a better understanding of the tools that we offer that can help you understand what is happening in your enterprise and help you solve some of the real challenges that you face every day. Now, first, let's talk about the state of the nation for just a minute. The reality is enterprise growth of cloud workloads is growing by leaps and bounds. We speak with customers every day who started out on AWS with a single workload, a toy project, a proof of concept, or a single AWS account that solves one problem for one point in time. And then before they know it, there's more accounts, more workloads, customer data in new silos, and rapid growth that leads to a new estate residing within Amazon Web Services. And some customers have hundreds or even thousands of AWS accounts. Now, that's a lot of moving parts. It's a lot to unpack. It's a lot of training that has to be done for staff. Things have to be operated securely and with stability. And the reality is that change is only accelerating, and it can seem hard to keep up at times. So this leads to the question, do you really need to sacrifice agility, modernization, and product development in order to remain compliant and secure? And how can I see what's happening in an ever-growing cloud footprint? Now, let's take a step back from the big questions for just a moment and talk about what composes these challenges, and then revisit the very first thing that every customer creates when they first start with AWS. And that's the actual AWS account itself. An AWS account is a lot of things. It's a security boundary, it's an isolated slice of potential for workloads, and it's a safe place to begin working with managed services. Into each AWS account, there are many managed services that customers consume without often having to think much about the overhead that they are now skipping, the undifferentiated heavy lifting of operating a complex environment. CloudWatch provides a pane of glass for logs and metrics across much of the entire environment that you're operating. AWS X-Ray is likewise a managed tracing service that customers can use to leverage deep understanding of their application's health and operations. And there's other tools as well, such as AWS Single Sign-On Service. There's GuardDuty, Systems Manager, and AWS Config, which is used to both record the history of changes to AWS resources and also remediate compliance issues if they are found. But then into this account, you also place your own workloads, EC2 instances, databases, AI and ML components such as SageMaker notebooks, containerized applications, Kubernetes, enterprise applications. Everything that you've ever operated on premises can be made to work just as well, if not better, inside of an AWS account. Now, then as teams move more and more workloads into AWS, the estate grows. Now, this can include anything from staging, development, UAT, SIT, production environments, as well as all the monitoring tools that go into these environments. Now, all of this represents a high degree of configuration management, and that's a challenge. Now, what about monitoring and alerting? You have existing processes for incident management and problem management, for escalation and break fixes. And now that you're operating a workload within AWS, you need to double down on being as transparent as possible to your stakeholders. And never opaque, always ensuring that everyone understands the state and the health of your workload at all times. And speaking of transparency, business metrics are often considered last by many IT teams, but are first and foremost for the C-suite. Why shouldn't business owners have real-time, live access to operational metrics and KPIs? The kinds of data that helps drive their real decision-making processes. Likewise, everyone has obligations regarding compliance and governance. This could be PCI compliance, GDPR, SOC, ITAR, or any of 100 other frameworks. against the backdrop of all of this is operational health. Are your sites and services up and running as you expect them to? What about deployment frequency, mean lead time to changes, mean time to recover, and change failure rates? These are key metrics that every enterprise is very well advised to track. And finally, you have to ask the question, are you well architected? AWS has an entire framework for helping you answer that question. And we've actually expressed it in 5 different pillars: operational excellence, security, performance, cost, and reliability. Eventually growing into a mature organization with sophisticated policies, governance controls, and a distributed environment with operations teams in multiple geographies, it's another challenge that people face. And every account can have the same complexity or more, and not everyone has the same mixture of custom-supplied data workloads and managed services. Then the growth continues and continues. In short, it's a lot to keep track of, and it can be a headache. Now, not everyone has the same challenges. It would be very inefficient to try to boil the ocean, and the challenges that we've listed here can be brought into a better focus by aligning them with roles inside of your organization. We have services and features that address specific needs and specific use cases for our customers, and we're going to highlight 4 of them here today and give prescriptive guidance on how these challenges can be faced with people aligned with these roles. So first, we're going to do a live demo of what the experience of a DevOps engineer or a site reliability engineer would be as they navigate through Amazon Web Services. Then, because it's still better to show than to tell, we're going to walk through the developer experience. What does an application developer do when they use AWS? How can they leverage our tools to the best advantage? We can't forget about compliance. So we're going to talk about the tools and the activities of a compliance officer or the chief information security officer within an organization. And finally, we're not going to forget about the business. So we're going to talk about business metrics, KPIs, and how you can evaluate if your workloads in AWS are achieving your actual business outcomes. First, let's tackle the role of the site reliability engineer or DevOps. Now, first and foremost on the minds of everybody who works in this capacity is keeping production up. It's priority number 1. Production always takes precedence. And people in this role will often ask the question, how can I get enough data to understand what's happening in so many places all at once? It's a lot of information to consume. So we're going to walk through the first of these demos here with the flow of data that every AWS customer is actually using today, whether they're aware of it or not, and whether they take advantage of it or not. Every EC2 instance, Lambda function, RDS database, Glue job, and nearly every other service that we offer is integrated into CloudWatch and provides metric data there that you can consume. Many services will deliver logging data directly into CloudWatch as well, and you can always use the CloudWatch agent to send metric and log data from an on-premises environment directly into AWS for analysis. Alarms are then created from these alarms and metrics to inform you when there has been unexpected behavior in your environment. And you can even use anomaly detection models with your alarms to tell you when things have gone sideways, even if you don't understand your own thresholds well enough. And then all of this is fed into a dashboard, either in CloudWatch or in Amazon Managed Grafana. And this isn't an either-or decision either. Each of these services can be used to best fit your needs. But staying in the world of operations, we would be remiss not to show Systems Manager. And a lot of the incredible dashboarding that you can see here in Systems Manager relates directly to your operations and health. So with that, we're going to roll into the first demo. Here we see the landing page of CloudWatch as it exists in one of our demo environments. In this particular environment, you're going to see a large number of CloudWatch alarms, and we're going to walk through how we've created these using an automatic process in just a few minutes. But first, when it comes to dashboarding within CloudWatch, there's a lot that exists off the shelf that you don't actually have to spend any real time or effort to create. A lot of these are found right here in the top left-hand corner, where we have your overview, which we'll walk through a little bit more briefly. There's also a cross-service dashboard that'll give you overall status of the services that you are actually leveraging inside of your AWS account. And even here, just having a really fast and easy look, we can still see rough counts of traffic coming to an application load balancer. We can see references to alarms that are generated in conjunction with these particular services that you're operating, and all kinds of per service metrics that are extremely valuable for diagnosing problems that exist in your environment. We can even view recent alarms that have been triggered in your environment, all in this single pane of glass. And we also have automatic dashboards. We will generate dashboard views for you using a procedural approach based on the activity in your account. This particular account, I leverage a lot of API Gateway. I did not have to build this dashboard. This is drawn for you automatically just based on the activity that your workload is actually generating. But now let's go ahead and walk through some dashboards that I've already created in this environment for us to have a look at. First, we're going to visit the so-called DevOps wallboard. So as implied by the name, the idea is that if you have a dashboard that is shared across an entire division, the kind of thing that you would have on the wall to at a glance always see the health of your environment. These are very straightforward to create using simple widgets, and we're going to walk through that process in just a moment. But even here, I've selected a subset of DevOps relevant metrics that should resonate for most individuals who work in that capacity. We're able to see number of requests coming to an API gateway. Here we have in milliseconds, the difference between the latency between an actual request to an API gateway and the actual servicing of the request by the backend resource. We also have the raw count of posts that have taken place to a particular API endpoint, data around SQS messages, alarms and their current status. This gray band that you see here on the API gateway, latency versus integration latency, that's actually an anomaly detection band. And we have the ability to generate this band on your behalf that you can use to create alarms and tell you when behavior in your applications is in an unexpected state or fails to match previously learned behavior over 2 weeks of observed data. We can also easily graph the activity across the AWS API control planes themselves. In this particular account, we can see that there is a high degree of activity related to X-ray samples. We're also generating data keys using KMS. We can visualize this data quite easily, and we can share this with a wider audience. So now I'm actually going to go through and add a widget to this dashboard. I'll just go up to the corner, click Add Widget. I'm going to look for something coming from metrics within the same AWS account. And here we'll be presented with the metrics browsing view. In this particular case, I'm going to look for something straightforward. I'll go to EC2 instances. I'm going to look at per instance metrics. And let's say that I want to look for CPU utilization for a specific instance. We can browse to it through here. We can then examine this data that we've selected, and even from just this one instance or from across a group of instances. It's fairly straightforward to create anomaly detection models or to do metric math based on this. Let's add this widget directly to the dashboard. There we go. And we'll make it a little bit wider. Now that we've added this widget to a dashboard and we can see visually what the CPU utilization looks like for this particular instance, it's a fairly straightforward process to add an alarm. And for this, we can go directly to the metrics view once again. by clicking the three dots up in the right-hand corner of that widget. This will pull us directly back into the metrics view. And from here, if we wanted to create an alarm based on the CPU utilization, it's as simple as creating the alarm using the create alarm widget. And from here, because we've already added an anomaly detection band, it's already giving us a preview of what that band may look like. We'll just go ahead and create an alarm. I will send a notification to an SNS topic in this particular case. And then with that, we are all set. It will take some time for the alarm to gather enough data to know the current state or health of this particular metric though. Now from this alarms view, you can very easily see that there is a vast amount of alarms that are created with this application insights prefix. Now, what's been happening is I've used application insights to discover the services operating in my environment and then create alarms for them automatically. I have not had to instrument every single component in my application to have alarms. Application insights has the ability to evaluate your workload and automatically instrument these things for you, including looking at log files, looking at metric data, evaluating Lambda functions that actually exist. And here we see all of the components that have automatically been discovered and instrumented using application insights. I'll also give a history of problems that have been found. I actually don't have any in this particular environment. Changes to the configuration of the application over time. And you can optionally add your own log patterns so that you can further enhance the introspection into your application health that application insights can yield. Now, CloudWatch dashboards themselves are not limited to just the account or region in which you're operating. And here I have a variant of the previously shown DevOps wallboard, but I'm now monitoring the application as it exists in two regions at the same time. And it'll give me a side-by-side view of the performance of this application, both in Oregon and in North Virginia. When you use cross-account, cross-region dashboards, you'll have this XA icon that indicates the source of other data that is being displayed inside of your dashboard. You can even combine metric data from other regions or accounts in the same widget. So again, you can have a side-by-side comparison fairly easily visible to your DevOps personnel. And finally, we're actually going to leave CloudWatch for just a moment and show a little bit of what is possible using Systems Manager. So dashboarding is not the domain of CloudWatch alone. Systems Manager has the ability to create ops items. It has an incident manager built into it, and you can add a high-level view, see a lot of compliance data about your environment. If we go quickly down to the bottom of the page, we'll actually see a breakdown of the severity of Security Hub findings or the current state of your account based on the AWS config rules that you have defined. For those not familiar with AWS config, this is a service that combines a configuration management database along with a rules and compliance engine. It can also optionally auto-remediate issues in your environment or create service tickets within other applications.
Thank you, Rich. So when I started working in infrastructure, the world was a lot simpler. There was a set of servers running my applications, and I can SSH into them and look at the logs. But a lot has changed since then. Modern application runs on a containerized orchestrated platform such as Kubernetes. They use serverless infrastructure and SaaS systems. So how can one get visibility into the system where you don't even have access to where your application is running. In fact, you don't even know on which server your application is running. But AWS observability tools are here to help. AWS observability services can help you gain insights into running application and reduce mean time to detection. AWS offers tools on all three pillars of observability. So for tracing, we have X-Ray. For logs and metrics, we have CloudWatch Logs and CloudWatch. And you can visualize all of that on dashboards like CloudWatch Dashboard, Service Lens, X-Ray Insights, and Logs Insight. So one can use CloudWatch Dashboard to build all these different signals which are coming from traces, metrics, and logs into one single dashboard. You can also do that. So this is great for someone who is starting new on AWS or want to use fully managed services. But you can certainly use open source solution. What if you are already using open source solution? For that, we have open source software as AWS managed service for observability. And that includes services like Amazon Managed Prometheus, Amazon Managed Grafana, our Open Search service, and AWS Distro for OpenTelemetry. Developers can collect logs using AWS Distro for OpenTelemetry and send them to services like Amazon OpenSearch because it also has a trace analytics capability now. Amazon Managed Prometheus can collect all the metrics, and you can use OpenSearch again for log aggregation. Now, all of this data can be aggregated in a single pane of glass or one dashboard on Amazon Managed Grafana. And I'm going to show you that in a demo. Now, for the first part of the demo, let's go back to Rich and look how a developer-focused dashboard can be built using AWS native services.
All right, so back to the CloudWatch console, we're going to head for the first part of this demo. From this page, we're not going to go directly into the same top-level dashboards where we were before. Instead, we're going to visit Service Lens Map. Now, what this view will give us is a graph that represents microservices, AWS services, and possibly even third-party services that have been interacted with across a microservices distributed application. This view is extremely useful for developers with complex systems that have multiple applications that will service a request in chain, and even some asynchronous applications that will need to send data into a queue for later processing. Some of the elements that we see here include step functions, as well as DynamoDB, containerized applications. We have S3 buckets represented. There's a number of different AWS services that are natively supported, as well as synthetic canaries. Now, our first stop is going to be examining some trace data that has been collected specific for requests that have not returned a 200 response code back to the requesting client. This particular request that I've highlighted was generated by a synthetic canary. And what we're going to do first is examine the traces that are related to this one specific request. So from this view, we're going to click View Traces. This is going to take us into the trace console itself. And as you can see, it has pre-populated a query for us, which is identifying the name of the canary that I am examining, and the client, which in this case was Synthetics. From here, we see a response time distribution that has already been mapped out for us. We see the 99th percentile is right around 186 milliseconds. We can also see a duration distribution. But if we want to examine specific requests that came from this canary, then we can simply click through and view it on this dashboard. And from here, we'll begin to see a waterfall view of the requests and how long each segment of this request took to actually service. Now, it's a little bit more of a deep dive than we have the time for today, but I'm going to quickly show that in the X-ray console itself, we have the ability to create groups that will match patterns with your sampled trace data. So trace data, of course, being, again, telemetry that is emitted by your application at runtime, which indicates its health, its well-being, what activities it's taken, and what other services your application is communicated with. In this particular case, I'm going to look at my not 200 group. Here we are filtering all of the traces that did not result in a 200 response code being sent back to the client. And even from here, we can click through to view a metric that has been generated by this group, by X-ray, that we can, as with so many other things inside of CloudWatch, we can add this data directly to a dashboard, or we can create a CloudWatch alarm directly from this data. And again, add that to our dashboard and increase the observability that we have affected across our environment. What I've shown so far is really just scratching the surface of what is possible using X-ray. And if we were to go back to the X-ray view itself, you'll see that there is a different view of service map. There'll be a different view of traces. And likewise, there's an entire analytics console that's available for us where we can compare traces across time, as well as an insights capability, which gives us automatic root cause detection. We can inspect these errors for the specific details of what has actually occurred. It will draw a map for us of the services that were involved in a problematic request, and it will highlight for us the actual root cause. And all of this data can be fed back into EventBridge, giving you the ability to have automatic root cause identification fed into a ticketing system or other ITSM process that you already operate. And with that, I'm actually going to hand things back over to Amelia, who's going to show some of the really fantastic things that you can do with open source tools, still leveraging cloud native data that has been collected and sent into CloudWatch.
Rich just demonstrated how you can use AWS native observability solutions to build developer dashboard. Now I'm going to show you how you can build similar developer dashboard with open source software available as AWS managed services. One of the most popular open source dashboarding software is Grafana, and we have Amazon managed Grafana. So I created a workspace with Amazon managed Grafana. So let's get right into it. Now, just to give you a walkthrough how I set up my environment, Grafana is a stateless dashboarding service which basically can pull data from multiple data sources. So I have configured 3 data sources, which is Amazon CloudWatch, so that I can pull metrics and logs from CloudWatch, Amazon Managed Prometheus, so that I can pull metrics stored in Amazon Managed Prometheus, and X-ray, so that I can pull traces stored in X-ray and put it on my dashboard. You can use community build dashboard and import right into Amazon Managed Grafana, and I'll show you with an example. So I'm going to try to create a dashboard, and instead of creating a dashboard, I'm going to import a dashboard. Now when I click on import, it allows me to pull a community built dashboard available on grafana.com right into Amazon Managed Grafana. So let's try to pull 3119, which is a Kubernetes dashboard displaying metrics available in Prometheus. Because I already have the dashboard, so it says name exists. So let me just give it a new name. And in the data source, I'm going to give Amazon Managed Prometheus, which I already configured. Now I already have an Elastic Kubernetes service running and Amazon Managed Prometheus getting all the metrics from that Elastic Kubernetes service. So
Let's import this dashboard and voila, look at that. How easy it is for me to pull a community built dashboard into Amazon Managed Grafana, which is pulling data from Amazon Managed Prometheus, which is displaying the metrics from Elastic Kubernetes Service. Developers loves correlating data from multiple sources, specifically observability data sources. So in order to solve a problem, in order to debug an issue, developers love correlating logs, metrics, and traces. Now, oftentimes, these data is stored in different data sources. However, you can use Grafana to build a single pane of glass and bring all three observability data, which is metrics, traces, and logs, on a single dashboard. So let me show you that dashboard as an example. So I'm going to open my dashboards and open this metrics, logs, and traces dashboard, which I put together for this demo. In this dashboard, I am pulling logs from CloudWatch logs. So you can see I have a log query. I have a data source as CloudWatch, and I have a query mode as a CloudWatch logs, and I'm querying these logs for my demo website, which is a pet application. And on top of that, I am pulling traces. So let's look into the traces. And for the traces, my data source is X-ray, because all my traces for this pet site is going to X-ray. And for my metrics, I am pulling how many pet searches are being done on that pet's website. So let's try to dig further into it. So I just narrowed down to the recent data. So my traces and my logs are automatically updated. I can drill into the log messages, or I can go deeper into the traces, that is the data coming from X-ray. So let's dive deeper into this trace. And here I can see the detailed trace view coming straight from X-ray. Now coming back to the dashboard, I just demonstrated how easy it is to pull data from different data sources like CloudWatch, Amazon Managed Prometheus, and X-ray into a single dashboard to achieve a single pane of glass. As seen in this dashboard, where we have metrics, traces, and logs in one dashboard. And I also demonstrated how easy it is to build dashboard leveraging community build dashboard directly into Amazon Managed Grafana, as discussed in the Kubernetes cluster monitoring dashboard, which we imported directly from grafana.com. Thank you very much.
All of this embracing of change, it's not without its risks, though. As any Chief Information Security Officer, compliance officer, or well-informed Cloud Center of Excellence can tell you. Now, the reality is, of course, that change requires ongoing vigilance in order to manage. And compliance does not stop when the audit is done. Just like vulnerabilities do not stop being discovered, and the internet itself does not stop evolving. Now, given that change is continuous, shouldn't your compliance be continuous as well? Now, there's a lot that can be said about CloudWatch relating to compliance and governance, but we're instead going to leave the world of CloudWatch for just a moment and show you how to use some ready-to-use, off-the-shelf tools that AWS offers for enterprise compliance. AWS Control Tower itself is purpose-built specifically for multi-account governance and compliance, and even has the ability to vend compliant accounts with guardrails applied from the moment that those accounts are actually provisioned. And AWS Config has the combination of a queryable configuration management database, as well as a rules and remediation engine that can be used to either notify or automatically remediate problems as they take place. And with that, I'm going to roll back into another real demo.
So on the theme of continuous compliance, we're actually going to first visit Control Tower. Now, Control Tower itself will operate in the payer account of an organization. So it's not going to be available for a child account of an organization. Our best practice is to operate your workloads in dedicated AWS accounts, separate from your payer account. And the reasons for this are numerous, a little bit more than we can go on into right now. However, visiting the Control Tower dashboard for this demo organization, scrolling down, we'll see some vital statistics about the entire account structure, all of the accounts contained therein, all of the OUs, and the guardrails that have been created to assure compliance in this environment. And right away, we see a list of non-compliant resources that have been detected across multiple accounts in the entire payer organization. And we see right here a list of the guardrails that have actually been violated. We can scroll through and we can very easily have a high-level view of our compliance status as it exists at this moment in time, bearing in mind that the mechanisms that produce these reports for us are automated and operate continuously. As well, we bubble up this information to the OU level. In this particular case, for this shared OU, I have at least one account that is in a non-compliant state. And that will show right here that the entire organizational unit itself is now marked as non-compliant. Scrolling down, we can flip through the accounts in the environment and see again which specific account is in a non-compliant state. From here, let's have a little bit of a deeper look into one of these accounts that is in a non-compliant state. I will go into this shared account. Again, from the view detail for this account, we show that it is non-compliant. We actually have external callouts to config rules that are not considered a part of a built-in guardrail, the landing zone version, and the state of the account. Accounts can be in an unmanaged state and still be in a Control Tower payer environment, and that will be reflected in the view of the account within Control Tower. Now, the non-compliant resources themselves, even though we're not in this AWS account, we can still retrieve some of their vital statistics, such as the resource ID. I'm actually going to copy that to my clipboard as we're going to make use of it in just a moment. And we can see here, the guardrail that has been violated is we have an EBS volume that is not attached to an active EC2 instance at this time. Now, of course, from this same page, we can also view the guardrails that are enabled on this account through the inheritance based on the OU that they actually belong to. And we can even view the AWS regions that this account is being governed within. So for example, we are governing this account and its compliance status in North Virginia, but we are not governing it in Sydney. Now, our next stop is going to be heading over to the config console so that we can have a more detailed view of the compliance status of these specific resources. When you first view AWS config from inside of the payer account, you are not going to be seeing all of the global resources from across all of the AWS accounts in your environment. We're actually going to head over to that view momentarily. Just for clarity, the initial dashboard view only shows the local account itself. And because I follow best practices, I don't operate active workloads in the payer account. Instead, we're going to go to aggregators. And in our aggregator view, we're going to be seeing data that has been collected from all of the governed regions and all of the governed accounts that are part of the Control Tower landing zone. And right away, we have a compliance status that's highlighted for us. And it is not a very good number. We have a lot of resources that have been discovered across all 13 AWS accounts, including Lambda functions, CloudWatch alarms, etc. We can click through and view all of these resources globally from the aggregator itself. And we don't have to actually access each of these discrete AWS accounts in order to enumerate these resources. I'll actually scroll over just a little bit so you can see we have the region and account number also available for us to peruse. Now, heading back up to the aggregators view, we're going to highlight a specific resource that we had seen earlier. So first, the non-compliant rules for all of the environment are going to be available. These are highly recommended to be propagated to a top-level compliance dashboard that should be made available for your compliance officers and CISOs within your organization. We have a list of non-compliant accounts based on the rules that have been violated inside of them, even conformance packs. But I wanted to go a little bit deeper. We wanted to examine that one volume that was seen earlier to have been violating a rule. And we have a very easy way of doing so using advanced query. In this particular case, there is a query that has been pre-written and is stored inside of the config console that you can take advantage of to search for non-compliant volumes. Making sure that we choose the right aggregator. We will find once again that volume that is in a non-compliant state. And we'll be able to see more of the relevant details about it, when it was created, what the tags are for this item, whether it's encrypted, the availability zone, and its actual state. So just like that, using the Control Tower dashboard capabilities and AWS config, your ability to, from a central location inside of your payer account in your organization, observe the compliance status of resources across all of AWS, all in one single console experience.
Thank you, Rich. Now, during pandemic, many organizations, specifically in travel industry, looking for ways to save cost on the cloud. They're looking for ways to increase their cloud cost efficiency. So all of the tools we discussed so far are developer focused, IT operator focused, but what about the business users? They're not necessarily being the AWS expert. So how can they get insight into what's going on into the cloud? How can they get visibility into the metrics like what is my infrastructure cost per visitor or what is my infrastructure cost per purchase on my site? They also need to know what is my infrastructure cost versus my revenue. Now, in order to help them, you don't need to give them an AWS console access, because now they can use single sign-on or SAML federated tokens to get access to the dashboard you built for them on CloudWatch. And now you can present information such as cost on the CloudWatch dashboard. Now, cost is not necessarily stored in CloudWatch already. The AWS cost information is either in AWS Cost Explorer or AWS Cost and Usage Report. With CloudWatch dashboard and custom widget, you can bring that information onto CloudWatch dashboard, make it available for your business users. And I'm going to show you that in a demo. And you can also use Amazon Managed Grafana instead of CloudWatch dashboard to build those dashboards.
The next in persona based dashboard, I'm going to show you finance and engineering persona to get insight into AWS cost. Now, the AWS cost data is primarily stored in AWS Cost and Usage Report and in AWS Cost Explorer. In this demonstration, I'm going to show you how you can bring data from these two places, which is AWS Cost Explorer and AWS Cost and Usage Report, into CloudWatch dashboard using custom widgets. So let's get into it. So I created a dashboard called AWS Cost. In this dashboard, on the left hand side, I am pulling in data from Cost Explorer, and on the right hand side, I am pulling in data from AWS Cost and Usage Report using an Athena query. Now let's see how we can build this. So I'm going to use a recently announced functionality called Custom Widget. As the name suggests, the custom widget is basically allow you to pull in data from any source. You code widget using Lambda and more. So let's get started. In order to make it simpler for you, CloudWatch team already built a multiple Lambda function to pull in data from certain sources. For example, you can pull in data from AWS Cost Explorer by using a pre-built Lambda function. In order to install that Lambda function, all you have to do is to click on the Cost Explorer report, and it will pull in the CloudFormation template to install that Lambda function. So I have already done that. So let's go back and click on next. In the configuration screen, it will let you select which Lambda function you want to call for this custom widget. So I'm going to select Cost Explorer report, and you can read the documentation. There's not much about it, and specifically for this Lambda function. And you can also preview how it's going to look on the dashboard. So this Lambda function is pulling in data from Cost Explorer, and that's it. And if you click on Create Widget, it will add this widget to your dashboard. Now for the cost and usage report, it is pretty much same. You can use the pre-built CloudFormation template to deploy this Lambda function called Custom Widget Athena Query. Now AWS cost and usage report is a file which is an S3. This custom widget Lambda function uses Athena to query the AWS cost and usage report and show you the result in a CloudWatch dashboard. If you read the documentation, it required 3 parameters: region, the database, basically that's the table name in Athena for AWS cost and usage report, and it also needs an SQL statement which you want to run on that table, which is AWS cost and usage report. So I have a select statement where I am selecting the cost from November 1st till date, and I'm grouping it by the product name, which is like an Amazon service. You can actually look at the preview how it's going to show up into your CloudWatch dashboard. So that's it. This is how you can pull in the cost data into your CloudWatch dashboard.
So that was the demo for building cost dashboard into CloudWatch using custom widgets. Now, we have shown you tools to make everyone's job easier. But let's break it down into how you can gain visibility your organization-wide. You can use tools like AWS Control Tower, which can give you multi-account visibility for your governance and compliance use cases. You can use CloudWatch to get account-wide visibility to understand what's running in an account and how many services and what services you are using. You can use AWS X-Ray to get further deep down and look at the workload level visibility. CloudWatch Service Lens is another tool which you can use to do that. AWS System Manager Explorer can give you visibility into the environment you are running in. So as you can see, there are different services can be used to get visibility and build dashboard according to the view you want to create, whether it's org-wide, account-wide, workload-specific, or your environment. At AWS, we believe there is no one-size-fits-all. And for that, builders want to have choice for the right tool for the job. As you can see, we mapped some of the services we have into the personas we talked about. For security and compliance persona, Control Tower and AWS Config can be used. For business owners, you can build cost allocation dashboard right into CloudWatch dashboard. For developers and DevOps persona, obviously Amazon Managed Grafana, Amazon CloudWatch can be used to gain insights into the workloads. So we talked a lot about all the persona-based dashboards. But what's next? First, you need to understand where is your data, and most of it might already be in the CloudWatch, and you can start leveraging that and build dashboards on it right with CloudWatch dashboard. You also can give access to the wider audience of your dashboard using SAML federated dashboard with single sign-on or identity provider of your choice. We also put together an awesome workshop. We call it as an observability workshop, where you can learn more about all of our observability solutions and what you can do and what areas you can gain insights into with those observability solutions. Talk to your account team or your account SA to get access to the observability workshop or have them run it for you. So thank you very much.